Hi, I'm Ali. Welcome to my calculus class. In a short video, I want to teach you how to evaluate trig functions by applying L'Hopital's rule. So, let's go to the lesson. Evaluate the limit of 2 to the x plus sine x over x as x approaches 0. Step 1 to solve any kind of limits is using direct substitution. So, plug in 0 into the problem, which gives me unsub 2 to the 0 plus 0, and on the bottom 0 as x approaches 0. 2 to the 0, any number raised to the 0 gives me 1. 1 plus 0 over 0, which is 1 over 0. 1 over 0 equals infinity, but you must determine what kind of infinity. Positive infinity or negative infinity. How? So you must split your problem into two parts. X approaches 0 from the right side, and also x approaches 0 from the left side. If x approaches 0 from the right side, I have 0 from the right side. And if x approaches 0 from the left side, on the bottom I have 0 from the left side. Any number divided by 0 gives me infinity. Top is positive, bottom is positive. Positive times positive gives me positive infinity. But for this problem, again, any number divided by 0 gives me infinity. Top is positive, but bottom is negative. Positive times negative gives me negative. Right side limit is positive infinity. Left side limit is negative infinity. Right side limit and left side limit are not equal, which means the limit of this function as x approaches 0 does not exist. Did you get it? Very good. Tell me about this one. Evaluate the limit 1 minus secant x over x squared as x approaches 0. Step 1, use direct substitution to realize what kind of indeterminate form we have. If I replace 0 into the problem, I get 0 over 0. For all 0 over 0 problems, we have the permission to apply L'Hopital's rule. How? By taking derivative of top and bottom of the fraction. The derivative of x squared is 2x. The derivative of 1 is 0, and the derivative of secant x is secant x times tangent x as x approaches 0. Now, again, use direct substitution to solve this problem. If I substitute 0 into the problem, I have 0 over 0. Now again, I have 0 over 0. What should I do? Applying L'Hopital's rule? No, it's really difficult because I need to take the derivative of sine x times tangent x. No, it's not. Of course, it's not a good idea. So, what can I do? Thanks to sandwich theorem, I can say the tangent x as x approaches 0 is equal to x. So on top, I have minus secant x times x divided by 2x as x approaches 0. X on top and x on the bottom cancel each other. Now, use direct substitution. If I replace x with 0, on top I have secant 0, which is 1. So on top I have minus 1, and on the bottom only 2. Minus 1 over 2 is the final answer. So keep in mind that sine u and tangent u as u approaches 0 is approximately equal to u thanks to the sandwich theorem. Like always, it's your turn to test yourself. Evaluate this limit as x approaches 0. Feel free to send your answers to me through comment section. Thanks for watching this video. Have a great day. Goodbye.